short answer is calculate the percent change in mass for something. You will not be given that formula. That's not really, it's not a formula on the formula sheet. It's a skill they want you to know how to do. So keep in mind, it's going to be final minus initial over initial times 100. The biggest mistake, because I've been grading the labs, that some people had on this is that if it loses weight, your answer should be negative. And I noticed some people in the lab that did not have negative. They forgot the negative sign. This one will not be negative because it gained weight. So it's going to be 12 minus 10 over 10 times 100, which should come out to 20%. So that's how you do a percent change problem. Again, if it loses weight, your answer should be negative. Do not do absolute value or something weird like that. It's definitely negative. All right, so whenever you do these kind of problems, there will always, 100% of the time, be some kind of a paragraph above the picture telling you what can pass and what can't pass. I highly recommend you read that because that's going to determine if everything can pass, it's going to completely change your answer than if only some things can pass through. So in this case, sucrose and water can pass, but not glucose. All right, so first thing you're going to do, you always want to look at solutes and you always want to look at water last. So first question says, at the beginning. When they say at the beginning, they mean before anything moves anywhere, when they first set this up. Is side A hyper, hypo, or iso to side B? So what is it? It is iso. The way you figure this out, you literally add them. So we got a total of 4 molar here, and we got a 4 molar on the right too. So this would be isotonic. But here's the thing. Since the membrane is permeable to different things, it may not stay that way. So you can't assume that just because it's isotonic when they set it up, it's going to stay that way. So, second question. What's the net direction that sucrose will move? And by the way, the reason it says net direction is because anything that can pass through is technically going to go both directions. If it hits from the left, it's going to go to the right. If it hits from the right, it's going to go to the left. But the net direction everything would go would be from where there's more to where there's less, if it can pass. So the net direction for sucrose would be towards A or B? Towards B, because there's less sucrose on side B. So sucrose is going to tend to go towards side B. All right, how about C? What net direction will glucose move? We got different answers here. This is a trick question. Not at all. Because if you read here, it says the membrane is not permeable to glucose. So be very careful. That's why you have to read the paragraph. Because if something can't pass, then that concentration can change. All right, now comes the hardest question of all. Most people got this wrong. Most people said water would go both ways equally. That would be the answer if only water could pass. Because if only water could pass, it's already isotonic, so water would go both directions equally. But sucrose could pass, and we just said that sucrose would therefore go to the right. So what's going to happen to the molarity on the right side? If sucrose goes to the right, the molarity is going to go up on the right side. In other words, it's going to become greater than 4. Because it's going to go from where there's more sucrose to less, right? So that means, and the molarity on the left side is going to go down. Therefore, the right side is going to become hyper or hypo? Hyper. So now the right side has become hypertonic. Therefore, which way will water go? Towards side B. This is the hardest question. If you said both directions equally, I know why you said that. You said that because you were basing it on the initial concentrations. But if they tell you that any of the solutes can move, you must consider which direction the solutes will go first, and then figure out the water. They will never ask you about the water without you considering the solutes first. Okay? So if the solutes cannot move and only water can move, then it would go both ways equally. But because some of the solutes can move, you have to send water. It's going to follow towards whichever side is hypertonic. So any questions about that? I would say there's a very high chance of a similar problem to this being on the test. I would say a very, very, very high chance of a problem that looks almost identical to this one being on the test. Oh, just letter D? There's a very good chance that there would be a question like D. So anything that can pass will go from high to low. So sucrose, we said, is going to go from where there's more to where there's less. So that's going to be to the right. They said glucose can't pass, so you leave that where it is. Okay, water's going to go from where there's more water to where there's less water. So the more concentrated this side gets, the less water there is. Remember, if we look at it in percents instead of molarity, because molarity is a little harder, but remember, if you had, for example, 5% solute on one side, and you had 10% solute on the other side, and only water can pass, how much water is technically on the left side? So technically, this is 95% water. And how much water is on the right? 90% water. So water is going to go to the side with less water. But that's also 100% of this time going to be the side with more solute. The more solute there is, the less water there can be. So in this case, we figured out that the side with more solute was side B. Even though we didn't actually calculate exactly how much water there was, the side with more solute will always be the side with less water. So, I mean, this will show you, how it works out, but you don't have to do all this work. This is hypertonic, water is going to go to the right side. But the reason why it's going to go to the right side is because the more solute you add, the less space there is for water. Where? In where? At the beginning. But if the sucrose goes to the right, we're now going to get, if the sucrose evens itself out, then wouldn't both sides then be 2.5 sucrose? Okay, so now if I add up my new numbers, 2.5 plus 2 gives me 4.5 on the right. And 2.5 plus 1 gives me only 3.5 on the left. So they're not even. In other words, you have to consider the water after you figure out what the solutes are going to do. So that's why it's not even. At the beginning it appeared to be, but because the solutes can pass, it changes things. Yes? Correct. If it had said water was the only thing that could pass, then the answer would have been both ways equally. Because it would have been isotonic, so there wouldn't have been a draw of water towards either side. Yes? At the beginning of the experiment, it's isotonic because when they first add everything, before anything has a chance to cross the membrane, you've got 4 molar on each side. So at the beginning of the experiment, it's isotonic. But it's not, at the end, it's not. Because of it'll get to that point again, but after the water passes. Okay,